We will finish out this module by recapping everything that we've covered about E1 and E2. Remember, we're talking about this overall elimination reaction, but the reaction can either occur via a two-step E1 type mechanism, where the rate determining step is the formation of the carbocation, or it can occur via a one-step concerted mechanism called the E2 mechanism, where everything happens simultaneously, and the key here is the transition state that's shown. If we look at the factors that we talked about with each of the two mechanisms, recall that both of them actually like tertiary or secondary substrates the best. The leaving group order is the same, so iodine is the best leaving group and fluorine is the worst. E1 mechanisms really are promoted best in a protic solvent, while E2 is not so picky and can occur in protic or aprotic solvent. E1 mechanisms will run with a weaker base, while E2 requires a stronger base. And finally, in terms of stereochemistry, both reactions will yield trans products as the major products when possible. And the E2 mechanism just sometimes it has to follow this anti-periplanar rule, so sometimes the trans product is not possible. So let's see how you approach this type of problem if you're given a set of conditions to try to decide if the mechanism is going to be E1 or E2. This is a tertiary halide, so it could undergo either one, but I see that it's a strong base, so I'm going to say that this is going to undergo E2 elimination. I'm going to go ahead and label the carbons as alpha and beta, and I notice that I have 2 beta protons on this side and only 1 on this side. Thinking about the E2 mechanism, then I think about the anti-periplanar geometry requirement, which you have to consider anytime you are drawing an E2 product, and you see that there's only 1 proton that's eligible to undergo that reaction. So in the end, there's only 1 possible elimination product via an E2 route. However, if we take that same substrate, tertiary, but put it in with just ethanol without the ethoxide, this is promoting more of an E1 type elimination reaction. And so you could have potentially either left or right protons be removed during the reaction because there's not this anti-periplanar requirement. So you could get the product from eliminating here, or you could get the product from eliminating one of these. Here are the 2 possible products, but you see that one of them is tetra substituted and one of them is only tri substituted. And so we end up getting a major minor product distribution according to Zaitsev's rule.